McCarthy. I lead the ML SecOps community at Protect AI, teaching you about AI security and machine learning security operations. And today I have the very special pleasure of being joined by Keith Hoodlet, who is Engineering Director, AI/ML and Application Security Assurance at Trail of Bits. Keith, it's good to see you again. Thank you for being here.
Likewise. I mean, it was like a month and a half ago since we had a conversation on the podcast, which was a lot of fun. It's fun to come now after some of the MCP security stuff has come out and get a chance to debunk some of that today, which is fun walking around, seeing everybody talk about that and being like, ooh.
Hot topic.
Yeah. Anyway, we'll get into that.
Yeah. So for those of you who may have been following us for a while, if Keith's name sounds familiar, as he mentioned, he joined us recently on the ML SecOps podcast, where we explored things like insecure pickle files to polyglot models, hidden risks in the AI supply chain. You can find that at mlsecops.com/podcast. And today we're going to dive a little bit deeper with you, Keith. Before we do that, do you want to talk a little bit about what you're doing at Trail of Bits right now and kind of how your current work ties into the intersection of AI/ML security and AppSec?
Yeah, absolutely. So for us, when it comes to Trail of Bits, we have an offensive security mindset with a real-world attacker perspective. So when we work with our clients, we look at their code, we look at their architecture, we look at their implementation, and we help them identify deep-seated exploits that they don't know are possible, that their SAST and DAST tools haven't told them about. And in addition to the AppSec team, as you mentioned, I also have my AI and machine learning team, which has done a lot of the research that went into the 4 blog posts that are now public on trailofbits.com around MCP security. So a lot of fun has been had over the last, say, month and a half, 2 months with that.
No doubt.
And we do all sorts of work when it comes to AI/ML security, from looking at the models to looking at implementation, to talking with people about how they vibe coded their application and all the problems that came with that, and everything in between.
Very good. So what are some of the most practical real-world threats that you would say either you, your team, in your own research are kind of seeing in the AI security landscape today?
So especially when it comes to prompt injection, I think everyone's seen and experienced that in some events. The interesting thing is oftentimes people will implement a model guard of some kind. They'll go out and they'll buy something from a vendor here, and showing them the ways in which we might be able to overcome that has been a really interesting experience. And then a lot of people will come back to us and say, well, what can we do, right? And I think for us, one of the recommendations that I start with is just limit the way that you're trying to summarize this page to alphanumeric characters, like just as a starting point, because tokenization gets really interesting when you look at, double wide character sets or other languages. And so in any event, we tend to see a lot of really interesting stuff in the prompt injection space, especially with our ability to use local models to seed inputs that consistently find jailbreaks and prompt injections. Outside of that, we are going to talk about MCP security, because that has been a whole new dumpster fire of things that we're starting to really crack open and show people the risks around that. And from there, recently OpenAI has said that they're sort of pulling back, or maybe I should say accelerating the pace at which they do their safety testing and doing less of it overall, I think is the general consensus. So we also offer the ability to look at hey, is this thing operating in ways that has reputational damage to you as a company, not just exploitation, of a bug that allows us to get remote code execution.
Right. And reputational damage, and as we look into the future and the possibility of additional regulation, possibly legal consequences, financial consequences.
Yeah.
Just don't know yet.
Yeah, absolutely.
So you talked about prompt injection, which by this time the industry has kind of recognized as a real-world threat, something that's serious that we need to be taking more seriously. I don't want to call it old news, but there are all of these new hot topics coming in on the tail of LLMs, prompt injections, and those types of things. Model context protocol is one of those really hot terms that's come up recently. So for folks who are hearing this for the first time, model context protocol, or MCP, it's a new standard introduced by Anthropic. It allows developers to send structured metadata along with prompts to language models. So kind of designed to give models better context for how they're being used, without entirely relying on natural language instructions like we're used to feeding into LLMs. That tends to open up new opportunities for precise and safer interactions, but it also raises questions about security, because you've got now this abstraction layer between your LLM or Gen AI and whatever data that you're trying to access. How do you think about that in terms of the AI security landscape and MCP security in general? And I know y'all have released several pieces now on Trail of Bits blog related to this.
So I look at it as just the latest and greatest opportunity for attack. That's the way we look at it from Trail of Bits. I mean, don't get me wrong. The intention behind this is really great. The ideas of being able to segment or silo these, model context protocol servers from one another, being able to use them to, integrate as a tool set or agentic tools that you can then have go and perform activities for you. Very exciting on the face of it. But we immediately found issues with this back in March that we were sort of sitting on and trying to figure out how, we'd recommend fixes to this. But first thing, when you connect to an MCP server, you pass a tool description from the server to the client. That is a prompt injection vector. We actually talked about that on our blog. Then you actually can do really interesting things where you can now steal entire conversation history from the way that they're talking with their Claude instance or other OpenAI or other model tools that they're using on the client endpoint.
Yeah.
Then you can use anti-terminal codes to hide all of your injection vectors and all of your malicious attacks to steal, API credentials or conversation history or intellectual property. And the one that we just released this morning is now you can also go and grab off of the actual MCP servers by attacking MCP server to another server, all of these stored credentials on the server endpoint as well. Including, by the way, and we actually found this on 5 different implementations of MCP, Google Maps, Postgres, there was also GitLab, Figma, and SuperArgs. So, and this is just the 5 that we looked at. I mean, everybody everybody here is probably creating an MCP server of some kind. We haven't looked at those yet. You probably should. And so implementations here abound with just problems. And it's exciting times in the security research space. I say, like, at Trail of Bits, we try to help companies make their glass houses safer, but we also throw stones at them to make sure that we find all the places that are going to break. There's a lot of stones to throw right now and a lot of glass houses to break with MCP.
Thank you. Are there any perspectives from Trail of Bits thus far related to agent to agents?
So we haven't looked at agent to agent yet. I mean, when you look at the protocol itself, it's a bit more complex than MCP. A lot of people are sort of scratching their heads because with MCP itself, you can sort of do the agent to agent thing anyway, just within inside MCP. But Google's been saying, hey, treat this as like an orchestration layer on top of MCP where you can actually have my model talk to your model. And it's a very interesting idea conceptually. I mean, there's a lot more instructions to it. It seems like it's probably a little bit more thought out and hardened compared to Anthropic's implementation. But we'll wait and see, right? I think that is going to be a fruitful area for research for us in the near future.
Yeah.
But we haven't looked at it yet.
Got it. Thank you. Okay, coming back to some of the work being done by your team and these awesome blog pieces that are coming out. When we last connected, Trail of Bits was preparing an article on trust on first use, or fondly referred to as TOFU. Where might attackers find leverage in the TOFU model when it comes to AI systems, trust on first use?
Yeah, so this is the very first blog post in the series is basically about exactly this concept, which is your MCP client trusts the server tool descriptions as soon as it connects and receives them. And so that's that whole trust on first use. In this case, we believe there should first be some sort of implementation to like have you inspect the actual instruction set before you trust it as a first point. But then also doing caching of that tool description so that when it changes, whether a new feature was added or an attacker suddenly has control of this MCP server and included a prompt injection, you now have the ability to say, oh, this has changed. I now need to review this again and approve this again.
Yeah.
So conceptually, trust on first use is the default by MCP as a protocol, and it probably shouldn't be.
Thank you. Keith, do you think there are AppSec practices or tools that translate well to securing AI/ML systems, or do we need a totally new playbook right now?
Yes. So
yes to both.
I mean, effectively, like all of the baseline things that you should be doing as a company, having encrypted backends between the way that your services talk to each other, having secrets management practices and doing secret scanning, doing static analysis. All of these things are just like baseline expectations, table stakes. And a lot of the vibe coded applications that companies are producing don't have these things.
Yeah.
We see it consistently. So that's maybe the starting point. There's also the capabilities for machine learning or CAML implementation from some research that came out of Google's DeepMind team recently that actually talks about inserting some sort of like a inspection in the middle where you actually have separated agents or separated LLMs. One is a instruction interpretation LLM, then you have the middleware, and then you have a agentic tool performing LLM. And that middleware can be used to create rule sets, to introduce some sort of security layer for user approval. It has its own burdens, and they talk about it in the paper as like, user fatigue and capturing every use case, which makes a lot of sense. But we see this as probably the right path forward for creating what will eventually become called like LLM firewalls. But the reference implementation hasn't been released yet. It sounds like they're working on a V2. We're excited to see it, and we will probably create our own reference implementation once we do.
Got it. So, Keith, you have a really broad background, especially in the AppSec space, and I'm curious, from your perspective and that particular experience, do you foresee any blind spots in the AI security realm right now that maybe a lot of folks aren't thinking about? Anything coming around the corner or top of mind for you?
So I'll leave this broad and then maybe try to get specific. So the thing that I see happening today is there's sort of two phases to a company. Make it work, and then make it good. We see a lot of the make it work phase, but that doesn't mean it's secure. And that doesn't mean it's written well or orchestrated well or integrated correctly. And so at a very high level, I think for companies thinking about what should they be doing, well, all the basics from a DevSecOps perspective as a starting point. The blind spots or the what's next is the agent-to-agent stuff and the MCP elements as well. I think as we start to see companies implement and integrate agent or agentic capabilities within their software, within their tool sets, within their suppliers' products, from an attacker perspective, that is going to lead to some very, very interesting breach events or compromises of software or client data getting leaked in ways that probably can't be predicted right now, at least as it stands today. If we get to a place where we have some sort of middleware that's performing firewalling of some kind, if we get a better control over control flow and data flow within the way that models talk to one another or perform agentic actions, we could be in a much better place in 6 to 12 months. I'm not sure we will be, but then again, this is a very fast-moving space in general, and so because of that, it's hard to predict the future other than to say, right now, we're not on a great trajectory. I think we can be on a better one in the near future.
We've been talking a lot in the community, Keith, about, to your point, this space is moving so quickly. And for the last couple of years, there's been a lot of heavy focus on like LLM security of AI systems. But with this advance to agentic AI and how all of that is evolving, tell me if you think this is fair. It almost seems like we're at this point of convergence of ML SecOps and DevSecOps. Like when you think about agentic AI, multi-agent systems, some of these systems that are going to be acting autonomously, analyzing, making decisions, taking actions without human intervention, there are going to be other types of traditional software, not just AI software, involved in all of this. And so it kind of exponentially expands the blast radius. Do you have any perspectives on that?
This is exactly why those teams report into me at Trail of Bits, because oftentimes what we end up seeing is when we get an engagement with a client and they're doing something with large language models, one of the members of the team that does that audit is from my AppSec team, because all of the attacks, attacking the APIs, attacking the way that they do input validation or output encoding, all of those things stay the same. It's just the new techniques that come in with machine learning or large language models to be able to determine how we can then achieve AppSec-related attacks using large language models as the sort of point of attack.
Yeah.
That's why we do things that way. And so to that end, I do see a huge overlap. I mean, within businesses, you don't have most businesses, there are probably some in the Mag 7 that have that. But you don't see dedicated AI security teams a lot of the time. That's because you just don't have budget for it. And so because of that, this is definitely an AppSec or DevSecOps problem within the enterprise. And I think coming at this from a perspective of understanding these things are somewhat unpredictable, the access that they have is very wide. And if you haven't done good data labeling and data segmentation, you're going to have a problem. because these things have access to the data lakes that these companies are connecting them to. The other side of this is if you don't have good logging, monitoring, and alerting of how these things are being used, you're going to have a bad day. Because at the end of the day, it's sort of like if I'm attacking this thing at 1,000 requests per second, no human is doing that.
Yeah.
And if you're not logging, monitoring, and alerting for malicious behavior, malicious activity, and agent or model drifts, which is a whole other problem that Helen Oakley just before this was talking a little bit about, if you don't have those things, you're blind, which is just not feasible for most businesses trying to implement this stuff today. And I don't think a lot of companies have thought about, there's now additional investment, additional budget that needs to be allocated to our AppSec program for this problem space. And so I hope executives here are thinking about that as they're looking at a lot of the companies like Protect AI around this problem space. Because if they're not, they're about to get blindsided by a bunch of developers connecting MCP servers to who knows what.
Yeah. One of the common things that I tend to hear within the ML SecOps community is related to, when you think of cybersecurity, some of the traditional pillars are people, process, and technology or tools. And luckily, places like Protect AI have come up with some amazing tools that are helping us approach this space. But when you're thinking about how to train up these teams, like you mentioned, there aren't AI security teams commonly within larger organizations yet. Do you see that becoming a thing? Or is this more a convergence of like ML practitioner teams teaching the security or AppSec teams a little bit and vice versa to make sure that those swim lanes kind of stream together occasionally? Or what does that look like?
I could see like a DevSecOps or an AppSec engineer specializing in this space. So I think it actually starts from the security perspective where you have someone that's really good at static analysis. You have someone that's really good with dynamic analysis. You maybe have someone who's good with offensive security research or penetration testing.
Yeah.
I think this becomes both a cross-sectional skill. So my teams, for example, everyone is in the process of, if not has already learned, all of the different prompt injection attack techniques that we can possibly learn.
Yeah.
But that said, when it comes to the hardening elements, that's going to become a specialization over time. Today, it's going to fall as a burden on some poor AppSec engineer in one of these companies that's now, in addition to all the other things they have to handle, this is just one more thing. So, and also, I mean, quite frankly, today, we don't have a lot of actual security practitioners who have this knowledge either. I mean, Trail of Bits is fortunate in that we have a really great team and we're exceptionally familiar with this stuff, but we also spend a lot of time and personal investment on that to make sure that when we talk with clients, they're ready to receive that information from us because we're very, very good at it. But in the Fortune 500, again, I'd suggest maybe 10% of them probably are in a good place for this and have the actual financial means to invest into very expensive resources who have specialization in this today. So the more we can skill up these people broadly and deeply, the better I think we'll be in this space. But as it moves so quickly, that's also hard to do.
Absolutely. Okay, well, we're certainly grateful to you and your team and Trail of Bits for the work that they're pioneering right now and the information that they're making available to the community related to AppSec, AI, ML security. It's wonderful to talk to you again and looking forward to seeing more.
Thank you so much. And also wonderful to talk to you again, Charlie, at least this time in person. So good to see you. Thank you for the opportunity to chat a little bit about this. And we'll probably talk again in another month and a half. And who knows, maybe we'll be talking agent to agent or some new thing.
There will be some new thing. Absolutely.
Awesome. Thank you so much.